Vanakkam. Welcome to this video on biomechanics. We have been looking at kinematics of reaching and grasping. In this video, we will look at a 3-link serial kinematic chain, planar kinematic chain. Forward kinematics of a 3-link kinematic chain and inverse kinematics of a 3-link kinematic chain. Consider this situation. There are 3 links AB, BC and CP of link lengths L1, L2, L3. Each of these is making the joint angle theta 1, theta 2 and theta 3 with respect to the previous link. In the case of link AB, it is making an angle of theta 1 with respect to the ground, right. So, this is known. The question is, can you find the coordinate of the endpoint P? Can you find this x and y? Given that I know L1, L2, L3 and theta 1, theta 2, theta 3. Okay. How do you do this? Similar to how we did it for the 2R case, we can proceed for the 3R case. Now, before we proceed to find the coordinates of x and y or the coordinates of point P which are x and y, we start by finding the coordinate of B which is x1, y1. What is this x1, y1? This is its x coordinate is L1 cos theta 1, is it not? x1 is L1 cos theta 1 and y1 is L1 sin theta 1, is it not? What about x2? This is x2. This is, remember theta 2 is the angle at the joint, rather the joint angle. This is the angle that the link BC is making with AB. So, with respect to the ground, the total angle will be theta 1 plus theta 2. Okay. So, if I wanted to write out x2, that is L1 cos theta 1 plus L2 cos theta 1 plus theta 2 and y2 is L1 sin theta 1 plus L2 sin theta 1 plus theta 2. Now, by extension, I am interested in finding x and y. X is L1 cos theta 1, okay, plus L2 cos theta 1 plus theta 2 plus L3 cos theta 1 plus theta 2 plus theta 3 and y is L1 sin theta 1 plus L2 sin theta 1 plus theta 2 plus L3 sin theta 1 plus theta 2 plus theta 3. I mean, this is the coordinate of the point P, that is the x coordinate and the y coordinate. Of course, we kept a notation that C1 is cos theta 1, S1 is sin theta 1, C12 is cos of theta 1 plus theta 2, S12 is sin of theta 1 plus theta 2, C123 is cos of theta 1 plus theta 2 plus theta 3, S123 is sin of theta 1 plus theta 2 plus theta 3. By substituting for C1 S1, C12 S12, C123 S123, we get x as L1 C1 plus L2 C12 plus L3 C123. Y is L1 S1 plus L2 S12 plus L3 S123. Okay. This is the coordinates of the endpoint P using forward kinematics. This is essentially a relatively simple extension of what we did in the 2R case. This is not very complicated. Now, let us move on to inverse kinematics. Remember that the inverse kinematics, even in the two-link planar case, was rather complicated. That is, in the two-link chain, right, when the coordinates are given, that is both x and y are given and link links are known, finding joint angles, right, is non-trivial, because there are two distinct configurations in which the same endpoint may be reached. We said this as elbow up, elbow down configuration. So, different configurations might lead to a given endpoint, at least two different, more than one will happen. That is in the simplest case of the two link chain. So, now we are looking at the three link case. Let us write down our notation for remembrance. C1 is cos theta 1, S1 is sin theta 1, C12 is cos theta 1 plus theta 2, S12 is sin theta 1 plus theta 2, C123 is cos theta 1 plus theta 2 plus theta 3, S123 is sin theta 1 plus theta 2 plus theta 3. One more thing that I am assuming here is I know the inclination of the last link with respect to the ground. The total inclination that the last link is making is something that I know. That is, I know the value of theta 1 plus theta 2 plus theta 3. Let me call this with some variable phi. This is assumed to be known. Okay. In the previous case, I only assumed the coordinates of the endpoint P is what I know, P of x comma y is what I know. But that will not be sufficient for me to solve a 3R inverse kinematics case, because I only have two coordinates. It will not be sufficient. So, I need an additional constraint. In this case, I am assuming that I know theta 1 plus theta 2 plus theta 3, which I am going to call as phi. Okay. So, this is a big assumption. We solve or we proceed with the solution with this assumption. So, for the inverse kinematics case, what are the knowns? Phi is known, remember, phi is known. Phi is known, L1, L2, L3 are known, and x and y are also known. What is not known? Theta 1, theta 2, oh, I am writing plus theta 2, theta 3. Remember, I know the sum theta 1 plus theta 2 plus theta 3. I do not know the individual values of theta 1, theta 2 and theta 3. I know the sum theta 1 plus theta 2 plus theta 3. This is what I know. I am interested in finding theta 1, theta 2 and theta 3. This is the problem at hand. Remember, I have already written in forward kinematics the value of x is L1 C1 plus L2 C12 plus L3 C123, and y is L1 S1 plus L2 S12 plus L3 S123, something that I have written. In addition, I also know phi, which is theta 1 plus theta 2 plus theta 3. This is what is known. I have also written down the notations. Now, what I am going to do, is I am going to define two new variables. I am going to define two new variables. I am going to call them capital X and capital Y. What is capital X? I am going to call this capital X as small x minus L3 C5. Essentially, this is this quantity, is it not? This is capital X. Remember, C5 is C123, is it not? Because phi is theta 1 plus theta 2 plus theta 3. So, C123 is cos of theta 1 plus theta 2 plus theta 3, which is C5. Okay. And capital Y is small y minus L3 S5. Okay. That means, what is this? What is capital X? Well, that is capital X and capital Y are those that are underlined, which is L1 C1 plus L2 C12, L1 S1 plus L2 S12. This is what we solved in the 2R inverse kinematics problem. Remember, this is what we solved in the previous video, in one of the previous videos, right. So, this is the 2R inverse kinematics problem. Now, I can proceed with performing the inverse kinematics similar to what I did in the previous case, right, similar to what was done in the 2R case, except the variables this time will be capital X and capital Y. Last time it was small x and small y. Other than that, there is practically no change, right. So, what I do is I am interested in eliminating, say, theta 2. I am interested in eliminating theta 2. What I do is remember what we did. I request you to please go back and review the previous videos. So, I am interested in eliminating theta 2, right. Then I will get 2x L1 C1 plus 2y L1 S1 plus L2 squared minus x squared minus y squared minus L1 squared equal to 0. Now, so if I eliminate theta 2, I will get 2x L1 C1 plus 2y L1 S1 plus L2 squared minus x squared minus y squared minus L1 squared is 0. Therefore, now what I am going to do, I am going to call this as some quantity small a and that as small and this as some quantity small b and this whole thing as some quantity small c. Now, there is this consider this right triangle with sides a b, with this psi as the angle between them, and the angle between a and b, sides a and b is 90 degrees. Okay, consider this right triangle as shown. I can get, using previous analysis or similar to previous analysis, I can write theta 1 as tan inverse of b by a, which is psi, that is psi plus, or as in plus or minus, because there can be two solutions for this, is it not, plus or minus cos inverse of minus c divided by square root of a squared plus b squared, is it not. perhaps we used a slightly different notation, maybe we used capital A's and capital B's and capital C's, does not matter, but this is the general principle. Does not. Now, similar to what we did in the previous video, I can find theta 2. How can I find theta 2? By squaring and adding the modified forward kinematics equations in terms of capital X and capital Y. If I do that, I will be able to find the value of theta 2, and that would be plus or minus cos inverse of capital X squared plus capital Y squared minus L1 squared minus L2 squared divided by 2 L1 L2. And now that I know theta 1 and theta 2, finding theta 3 is easy because I know what is theta 1 plus theta 2 plus theta 3, which is phi. So, then theta 3 would be phi minus theta 1 minus theta 2. Now, a question is, can you do this without assuming phi is equal to theta 1 plus theta 2 plus theta 3? Can you do this? The answer is no. If you do not know the sum of theta 1, theta 2 and theta 3, or rather if you do not know the inclination that the final link makes with the ground, if you do not have this detail, you will not be able to find theta 1, theta 2 and theta 3. Remember this. These kind of manipulators in which there are only 2 equations, but there are 3 unknowns to solve, these kind of manipulators are called redundant manipulators. Because a particular point in a plane can be reached with more than one configuration of the links. That is true even in the 2R case, but in the 3R case it is super redundant, because if you take a particular point, many different configurations of the 3 links can reach to that point. So, with this we come to the end of this video. So, in this video we saw a simple 3-link planar kinematic chain, forward kinematics of a simple 3-link kinematic chain, and inverse kinematics of the 3-link kinematic chain. Importantly, we assumed that we know the sum of the 3 joint angles theta 1, theta 2 and theta 3, so that we can compute their individual values. If you did not know the inclination that the last link makes with the ground, you cannot compute the individual joint angles, because the entire manipulator is redundant. There will be many solutions to one particular this, because there are 2 equations and there are 3 unknowns. You cannot solve for this. Thank you very much for your attention.